Okay, I mentioned certainly the video that I do recommend you watch. It's somebody else solving this particular problem. And what I'm doing over here is, I got the visual already. I went through that. I'm going to say roughly my solution is around 1.5 for this problem over here. I did mention the guy that does this video uses Lambert W function. You may want to look into that. And I think it's very popular now on the internet. Newton's method is what I'm using. He mentions it. I'm using Newton's method over here. And I said I'd do it using Sage. So what I want to do is I want to go through that with you. I'm going to open up my Sage application, and I'm going to type it in. It's a coding language. And what do I type in? The first thing I type in is reset. And reset gives me a clean slate. And then I go type the function in. So what's the function? It's this thing here, this equation solved for 0. So I'm going to say f of x. Now that equation solved for 0, I'm going to say it's x squared minus 1. Let's see. Divide by the natural log of x. Now in Sage, the natural log is just log. That's the natural log of x. I'm dividing by that. And now I'm going to do subtract 3 away. All right, that's done. Now what I want to do is I want to use call to Newton's. I'm going to write the function down for that. Newton's method. Pretty easy to type in, by the way. It's a function. The function is going to be that f of x, the x, the guess, minus f of x divided by the derivative of f of x with respect to x. Now you notice I'm not actually getting the derivative. I'm letting a machine do it for me. The next thing I got to do is I got to tell it a guess. And remember I said 1.5. That's my guess. The next thing I want to do, I want to use Newton's method to get a better guess. So I say x equals Newton's method, evaluated at x, and remember x is 1.5. So what's this going to do? It's going to call a function, Newton's method. It's going to evaluate 1.5 and then assign it to x. Now I want to display the x, but I want to approximate it. I don't want some kind of wacky looking long expression. I want a nice decimal number for that, and hit the return button. And what do I get? I get 1.4644. I do want to go back to the grapher application and point out, you know what? I'd take 1.5 was my guess. Grapher's giving me this over here. All right. Again, it's a 4-digit, 4 places after the decimal point, which is not bad. All right. Now, what I'm going to do is I'm going to say, this is now what x is. It's 1.4644. Blah blah blah. If I do Newton's method again, I'm wondering, does it change? All right. So I just use the up arrow to call it back again. What do I get there? Well, I'm looking at it. It's a change. It's not a big change, but there is a change between those two numbers, by the way. I clearly see that. I'm going to call it again. I'm using the up arrow just to call it back again. And what do I get over there? Did it change over there? Yeah, it changed. I'm looking at the end digits, by the way. Let me do it again. I'm going to keep doing it until it doesn't change. I'm going to say right there, it looks like those two numbers within the precision of the machine, it's not going to change now. All right, it's not going to change. All right. Now, what am I saying over here? Whatever that x value is, I'm saying f of x would be equal to 0. Let me see if what happens over there. Now, granted, I'm going to do numerical approximation again, and that should be 0, by the way. Now, granted, when I get it, it says it's 0. Now, the truth of the matter is it's really not 0. Within the precision of the machine, it's 0. All right? Now, granted, you notice it's got a bunch of decimals over there. Decimal places. The bottom line is, in precision machines, it's really 0, by the way. And that's why Newton's method is saying this number over here. And that basically calls it out. But again, I want to point out, I would strongly recommend you watch this guy's video. All right? The reason for watching the video, you're going to see him do a different method. And you might be confused by that. I'll be honest with you, it's good to be confused, because when you're confused, at least you're attempting to learn something, and you want to try to remove that confusion, all right? But the Lambert W function right now, in my opinion, is super popular on YouTube, all right? This guy uses it a lot. Other people use it a lot. It just keeps popping up, by the way, all right? Thank you.